Awesome. Well, welcome everyone. This is the July ROS Seattle Meetup, virtual meetup. Today we have an exciting speaker, Lou. He's the principal software development lead at the Azure Edge Robotics. Um, and But I think locally we know him as a local ROS enthusiast, and he's been working on bringing ROS to Windows for a while, or just general like large robotic systems, um, uh, powering a large robotic system um, in that area for a while. So today he'll be talking about ROS extension for the popular editor Visual Studio Code. And without further ado, please go ahead.
Well, thank you very much for that introduction. I really appreciate it. As Michael mentioned, I am the development lead at the Azure Edge Robotics team. It's a smaller group within our Edge platform team. Recently, I had worked on Windows IoT, where we actually brought ROS to Windows. So some of the work that I'm going to be showing here today is actually running on Windows, but we're also going to be doing some work remotely on a Jetson Nano. And we'll show both ROS 1, ROS 2, Windows and Linux. So hopefully we'll be able to get through all of that. If you're interested in some of the other work streams that our team works on, you can check out aka.ms/ROS. We've got quite a few ROS nodes, some cloud services, and of course, Visual Studio Code ROS extension. The ROS extension was originally started by Dr. Andrew Short, who's out of, I believe, Australia, as part of a grad student project. When we brought ROS to Windows, it was actually a little bit hard to develop on. So we were trying to set up a solution that leveraged some existing work streams, specifically this work from Dr. Short. When we reached out and said, hey, we want to do some work in here, he said, you know, I'm not doing a lot of robotics lately, so do you want to just take it and run with it? So we did. We worked with our team to transfer ownership, and we re-released it. So that's why you'll actually see two different ROS extensions. One is listed as deprecated. We are currently and actively working on the ROS extension, targeting both ROS 1, ROS 2, Linux and Windows. And I'm also told it works pretty well on the Mac, although I personally haven't tested that. So let's talk about the VSCode ROS extension. I'm going to switch over to a quick PowerPoint. I need to be over here. Let's see. So as I mentioned, it works on multiple platforms. A couple of key features, core status, so you can see whether or not ROS Core is running, or the ROS 2 daemon. You can launch a debug from a launch file, one or more ROS nodes, and be able to step from one ROS node into another, depending even on multiple processes. So that's really useful. It works on C++ and ROS, or Python today. So you can actually step from a C++ node into a Python node and then back again. We were talking earlier about ROS2.NET as part of another work stream. I'd love to be able to add that support and maybe even the ROS2 Rust support in the future. And I'll show you a slide on that. It also supports URDF preview, Uniform Robot Definition file, which is a description of your robot, the physical connections, the physical attributes of the robot. Can be kind of difficult to edit traditionally, but we're using the ROS Web Tools to actually provide a preview with inside of VSCode, so that as you edit your file, you can actually get a live preview. We're looking to add a bunch of features to that, and we'll talk about that as well. It also supports terminal from within VS Code, so that if you're working on a remote robot or WSL or even locally, you get a ROS terminal that you can provide, you can use for using ROS commands. So you can get VS Code through the marketplace, aka.ms/ROS, which is the root of all of our landing pages. /VS Code will take you to the marketplace, and you can install it from there. or you can install it from VS Code, the extensions tab. So a rough roadmap. This was actually from a TSC meeting, ROS2 Technical Steering Committee meeting recently. Bug fixing. Lots of churn, lots of things happening. We do find a lot of edge cases, things that are not quite right. So we do spend a lot of time on bug fixing. Get a lot of requests for videos and walkthroughs. So I'm doing this today as a live walkthrough, a live demo, but we would like to also do some things that we host on YouTube, Odyssey, those kinds of things, as well as textual walkthroughs for if you just want to figure out that one thing. Containers are becoming relatively ubiquitous in robotics. So we are working on improving our container support. I'll show you how to do remote container development with ROS2 running on a Jetson Nano as part of this walkthrough. And we're also looking at what it would take to improve the working with multiple nodes. Specifically, if I fire up 5 or 6 nodes, know what should be debugged, what shouldn't be debugged, how to stop them all at the same time, or even target this node runs on that compute unit and that node runs on that compute unit. So those are some of the things that I'm actively working on. What would you like to see? This is something that I would love to hear from the community. Some of these are actually referenced on the VS Code GitHub. Some are things that we're interested in doing at some point in the future. So feel free to publish any feature requests or issues on the GitHub, and we'll respond in kind. Some things that we'll immediately want to introduce: ROS2 test debugging. We have it for ROS1, we don't have it for ROS2. WebViz integration, CondaForge integration, which allows you to use CondaForge for deploying ROS on Windows, Linux, or Mac, and actually have it work within VS Code, or deploy through VS Code. So some of those things. So I do have a few asks. This was originally TSC asks, but if you like the VS Code ROS extension, please do rate and comment on the marketplace. That does actually help us. You know, if you ever feel like you want to put one, go put an issue in and I'll try and address it. But if you can rate and comment, that'd be great. Help us prioritize. What do you want to see? Go thumbs up a work that you'd like to see, or if it impacts you. Feature requests, contributions are always welcome. Okay, so with that, I'm going to switch over to a walkthrough starting with ROS1. But before I do, was there any questions on anything on the slide deck? Okay, so let me switch on over. Okay, so this is a traditional VS Code. I currently have a couple of extensions installed, including the ROS extension. I'm not going to bore you with actually going through and installing them, but I will show you where you get them. So first, you click on the extensions on the tab here. And if you search, you can find the ROS development environment for VS Code. Okay, and close to 160,000 installs, which is awesome. I'm in the process of updating the documentation, so it'll be a little easier to read and find the walkthroughs and videos. I currently have a ROS1 workspace opened up. Okay, so the ROS1 workspace, we're actually using our Onyx model workspace, which includes a camera and a ML ROS node. In order for the VS Code ROS extension to detect a ROS1 workspace, you actually do have to build it first. So you can do a catkin make and build it, and you'll find a catkin workspace. If you're not familiar, catkin is one of the tools that you use to build ROS workspaces and work with packages and dependencies. Let's show some other things here. Down at the bottom, You can see I'm making some fixes for multi-camera, so that's a feature of VS Code. We have the one of the features of the ROS extension is whether or not your ROS core is running. In this case, I'm running ROS1 Noetic. If you click on that, you can see that we're offline. If I wanted to start core, you press Control-Shift-P. This is a feature of VS Code called the command palette that allows you to exercise commands in all of the various extensions without cluttering up your screen with toolbars. Okay, so first I'm going to go ahead and start the core. Okay, so ROS start. Okay, so in the background, what the VS Code extension is it's sourcing the environment and actually running ROS core so that it starts up underneath the covers. And you can see now we have a checkbox that says ROS Noetic has been started and the core status is here. As we launch ROS nodes, this will be updated as well. Okay, so that's the first feature. Okay, let's talk about some of the other features. Control-Shift-P. If we type ROS, you can see that we have quite a few ROS specific commands. Updating C++ properties will actually set it up so that IntelliSense works. What else does it do? Yeah, pretty much IntelliSense is the big one. You can run ROS tests. You can use ROS dep right from here. You don't have to remember that long command. You can create cat-in packages, although it's not terribly useful today. One of the backlog features we have is to make this more discoverable so that when you create a package, you can actually get a list of, here's all the messages you want, here's the dependencies you can choose, and we'll automatically inject those. So that's on the backlog. Let's see. Cool, let's go ahead and create a terminal. So this is a ROS terminal that has the ROS environment sourced. So you can see if I type, oh, that's interesting. ROS pack find. Okay, so you can see that we have ROS sourced in the environment. You can use the commands that way. I'm just going to go ahead and close out of that. And then we'll show the next step. Before I go any further, does anybody have any questions? Feel free to type into the chat. Any chance you can share your screen instead of doing a background presentation? No, unfortunately, I have to do it this way because of reasons, but I can't share my whole screen, and I do need to bounce back and forth between things. Is there a problem with doing it this way? This comes from Jeff. Okay.
Sometimes it shrinks your screen down to being just a small little screen with everyone else being shown as well. And at that point, we can't see the background of the presentation and can't read it. So
is it full screen right now?
Now it is, but before it wasn't.
Oh, okay. Thank you for whoever made it full screen. I forgot to go do that myself.
I have some question.
Sure.
For the C++ properties, can you elaborate a bit more on that feature? Is it like IntelliSense for showing all the like auto completing the property names or function names and stuff like that, or more?
Yes. So what it does is it actually will inject into your workspace. It'll update the C++ properties JSON with the generated files from your project as well as for ROS itself. That's on top of your build environment. So it injects the paths necessary for IntelliSense to pick up ROS, VS Code, Noetic, and your local environment. So that's what updating the C++ properties does.
And if I use something else than Catkin for building the packages, how well will it integrate, assuming that I will keep all the installed directories intact, like the structure intact?
That's a fantastic question, and that's actually something that I'm working to improve. Right now, in order to prevent some deep walks that we need to do, we do key off of certain attributes of the workspace. So for a catkin workspace, it does drop this file, catkin_workspace. We do use that as a trigger to detect a ROS1 workspace. For ROS2, it's actually a little more interesting because we do actually go one step in and say, do you have a source directory? If so, does it have packages? If it has packages, well, then it must be a ROS workspace. And so we do some triggers for ROS2. If you are using the catkin tools library, it generates a different file that we use to key off of catkin tools. Now, where we use that, so let me just go ahead and open up a C++ file. So if I press Control-Shift-B, actually, sorry, Control-Shift-B, you can see that it detects this workspace as a catkin workspace, and I can run build right here. Okay, so it'll go through and run the build. Close that out. This is your debug tab right here. If you don't have a launch file, we will generate one. And the way we generate it, I'm not going to show you because it does take, I have it set up for this, but when you click create launch file, it will bring up a list of packages that you can select your package and then your launch file. And it will generate the launch configuration, which looks like this. Okay, so in this case, I have a ROS node that we're calling the Onyx ROS node, and I'm launching a tracker launch file in that workspace. Okay, so if I click start, what's going to happen is that we actually process the ROS launch file using ROS Launch and enumerate all of the executables that will be launched, plus what ROS Launch says that it should, that executable should be launched with. Because ROS actually has parameters for every ROS node outside the process that have a key. And that key says for this node, when you ask me for a parameter, you pass this key and I give you back your parameters. So we have to dump that and attach to each process so that the parameters work. Okay, so in this case, we are launching the camera node and our ML ROS node. And if we click on the noetic, you can see all of the parameters are launched correctly. And you can see that we have a bunch of ROS nodes that have started. Okay, so this is how we can verify that we've launched it. We have two contexts in this case. I have a camera node and an ML node, and we can switch between them, and we can also set breakpoints and hit them. Okay, so I'm going to switch over to RViz now and just show that working. Maybe. Let's see. Does it pick it up? There we go. Okay, so we have RViz running on Windows. You can see that we have our display environment, and then I'm going to go ahead and add an image. In this case, I'm going to add the raw output. Okay, so you can see my green screen in the background and my nicely taped microphone, which hides it. I'm also going to switch to the output of the debug output from our ML ROS node. Okay, so you can see that it's detecting a person. And we also have a position tracker, but I won't show that today. So let's go back here. Any questions so far? So this was opening up, using VS Code to connect to a ROS graph. We'll start the ROS graph, introspect it, set up a debug environment with multiple ROS nodes that you can connect to. Although I didn't actually show you debugging, so let's go ahead and show that real quick. So in the camera ROS node, let's see. Here's a good place to put a breakpoint. Let's see. How about capture frame? There we go. Okay, so we actually are hitting a breakpoint. We have the sample of the image coming in. We can also take a look at the this pointer, break out the node handle, video source path, camera, frame URL. So you can see all of the properties on your objects are there as well. So that is ROS running locally. Okay, so some other features I wanted to demonstrate. I'm going to go open a recent workspace and open up our Jackal workspace. So the ClearPath Jackal is one of the robots we have we work with. I actually have it under my desk over here. It actually has a pretty cool looking Zacro file. So Zacros or URDFs are descriptions of the ROS robot. So we can do Control-Shift-P and bring up URDF preview, which brings up a live preview of the robot. And you can zoom in, move it around, rotate. Some features we'd like to add here, joint simulation, so you can slide and see things move around in the URDF. Frame visualization, so you can actually turn on your TF frames and see how they connect in. What else? This is just the URDF previewer, not the live visualizer. We would like to include webviz.io, so you can see that right in line as well on a running graph. So that is ROS 1 in a nutshell.
What is the URDF preview written in? In like programming language or something? Is it part of the ROS extension?
So it's actually a open source project called ROS Web Tools. And that's something that we reference and we attribute in the documentation. It's fetched live, so it comes on live, but our ROS extension sets up the environment and then opens up a web view inside of RViz or inside of VS Code that pulls in the ROS Web Tools. It's written in JavaScript and 3.js, and there is a JavaScript library for interacting with a living ROS graph over the ROS bridge. So hypothetically, it could be used for visualization. We're just using it for preview.
Cool, thanks.
No problem. Okay, so we're going to switch over. One of the extensions that we're going to demonstrate here is the remote extension. Okay, so you can install the remote container and remote SSH. These are two features of VS Code that allow you to reach out to other devices and operate as if you were running it locally. Okay, so to access that, we go down here to this open remote window. And I'm going to connect the current window to host. Okay, I have a couple, including my BB8, which maybe I'll show a little bit later. But I have a Jetson Nano that's connected. Yes, I know I need to update. I didn't want to do it before a demo. Okay, so in the remote folder, I have the the bash terminal is here. And I have a workspace, which has the JetBot workspace. So I'm going to go ahead and open that folder. This is now browsing on, I'm on Windows. I'm browsing remotely a Jetson Nano over my network. So this UI is running Windows. What's inside of it's actually running on the Jetson. And so I'm going to go ahead and open that workspace. Okay, so now as it's starting, you can see that I have the ROS. So I didn't show this, but now that Visual Studio Code is connected to the JetBot over SSH, it says, oh, I don't have my backend installed there. So it actually does a remote install of the Visual Studio components into the Jetson Nano. But I had ROS installed on my desktop. It's just not installed on the Nano. So you actually have to go through the process of installing your ROS node. So going to extensions and actually installing it remotely. Once it does, then you get all of the experiences that you'd expect from a running ROS graph. Okay, so like, for example, even if I do ROS Core. So if I start ROS Core here, I was just demonstrating it from a terminal, but you can see that we also detect that. Control-C works as well. Let's see, do I have ROS? I'm going to go ahead and just do a ROS launch on the RealSense Camera. And we're going to do ROS D435 camera with model. And so that's actually going to run, oops. So this is actually a regular terminal, not a ROS terminal. So we're going to do that. And then ROS pack find. Oh, that's neat. Okay. Oh, sorry about that. ROS launch, ROS, RealSense to camera, ROS D435. Did I spell it wrong? Yes, I did. Okay, all of that to say that we are now running remotely using the VSCode extension, although you can also do launch debugging.
Hey,
So,
Lou.
yep.
Do you mind walking us through how you connect it to a remote device? In this case, the Jetson Nano?
Yeah.
Thank you.
So this button right here is the SSH extension. Okay, so I am set. Oh, I think you're asking for how did I set up this file here?
Yep.
Okay, so let me go ahead and close out this remote. So when using SSH, I'm currently using an SSH key that I had to transfer over to my Jetson Nano using SSH copy ID. I'm not going to show that because IDs and stuff, but I also have a configuration file. I don't think there's anything wrong with showing this, so maybe I'm being a little more paranoid than I should be, but so I have a SSH config that has the IP address of my various systems, and I will change these right afterward, by the way. But I have a user on the system that I've initialized with the SSH key. So this is running on my local system. If I change something, you know, and then I try to connect to it, you can see that the SSH extension will pick that up. Okay, so it's just a config text file. So when you connect to that host, connect the current window to host, just a static IP address that I have for my Jetson Nano. Is that helpful?
Yep, thank you.
Sure. Now, I don't remember, did I actually launch the RealSense camera? Oh, no, I didn't, because it turns out I needed the camera cable and I didn't have an extra cable. Well, neither here nor there. Trust me, you can launch the RealSense camera and it runs. I needed the cable for that camera, which I'm not using anymore. Hold on a second. Okay, so Melodic is offline. We'll go ahead and create a terminal. We'll ROS launch. D35 camera with model launch. Okay, and we'll switch back over to RViz. Now here's a neat trick. If you actually want to connect RViz to a remote system, there's a couple of things that you want to do. Okay, so the first thing is you actually want to set the ROS master IP, both your IP for your local system and the remote URI for RViz. And when you launch RViz, it will now be connected to that remote system through those environment variables. Okay, so we can go ahead and open up point cloud. The point cloud, no, it's depth. And seems like the RealSense camera is not happy at the moment, but I'm going to leave it at that. It's probably because I ran out of space on my SD card. Okay, so that was remotely connecting to a Linux system using the SSH extension or SSH extension and then RViz over SSH. But there's one more thing I wanted to show, which is actually connecting to a container remotely. Now, we're using Docker as a container manager, and we have a Docker extension. Docker supports what are called contexts, where you can set a remote context. You can say Docker context create, and in this case, I have a nano context. Oh, that's because I'm on the nano. Sorry about that. I'm now back on my host system. So we have multiple contexts, including the nano context, which I created with Docker create context, context create nano, and then you add the SSH connection to your Docker. And you can do things like go ahead and run a container. Once you actually run the container, you can then actually install the VSCode ROS extension into that container. Okay, so we're going to go ahead and attach VSCode to that running container. And you can see that this is the Dusty's from NVIDIA container. I don't actually have a workspace injected into it, but at this point, you can actually go ahead and install the ROS extension into that container. And it will work just as if it's local or over an SSH connection. Anyway, that's all that I wanted to share today. I think that was a little bit longer than half an hour, but I hope that was useful. I do see that there's a couple of questions in here, so I'm going to go through and answer them. And then if you want to pop in and ask, that'd be great. Having the ability to run ROS on Windows is awesome. Does that mean we can also run SLAM algorithms like orb slam 3, MATLAB, or as a ROS dependency? We actually do support several, or have ported several SLAM algorithms, although orb slam has not been one of them. We do have some resources to help port to Windows. But if you have specific ones, we do actually have a GitHub, that's linked off of aka.ms/ROS that you can put requests in, and we'll take a look at them. We have a cartographer, Carto, Gmapping. I think even eSlam works. So there are a bunch of SLAM algorithms. Orb has been on my list to do. Let's see. You have a Linux package. You have a package with a Linux dependency. It must run in the OS. You can use a Linux container on Windows to run certain types of Dockerized work streams. So anything that doesn't access hardware. You can also use WSL, but it does require, if it requires hardware access, only certain types of systems are hardware supported, including the GPU, but not serial or cameras. Yep, WSL2 works great. With some of the new WSL2 support, you can actually run Gazebo from WSL and have it compose up on your desktop as opposed to running it natively on Windows. Yep, and eFlow Edge for Linux on Windows is a recently announced feature of Windows for supporting IoT Edge IoT Edge containers on Windows. Thanks, Pranav. Okay, that's all I had. I'll be here for the social afterward, so I yield back to the floor. Thanks, everyone.
I have one question.
Oh, sure.
Yeah. Any subtleties for in communicating between Linux ROS, and I noticed that you were able to communicate with remote ROS master running on Linux with your Windows environment,
Mhm.
ROS running on the Windows environment. Any subtleties that one might want to know when you are sort of across between two OSs?
Yeah, it's a great question. Most of the one subtlety that we do know of is around MDNS. So if you use, you do need to use IP addresses. MDNS doesn't quite work the same way as it does on Linux. It can be made to work, but it's not the same as how you would use it on Linux. Otherwise, we haven't had run into any transport issues running between Linux and Windows, even on multiple different compute units, some Windows, some Linux. In fact, one of the systems I'm working on is being able to run ROS on a Surface Go with an iPega joystick as a ROS console for my BB-8 running with the Jetson Nano. So yeah, works pretty well. On DDS, if you're using ROS2, if you're using the same DDS provider on all systems, it works great. If you are using different DDS providers, that's when things, there's wire protocol differences between DDS providers that might cause problems. That's a great question. Yeah.
Hey Lou, in my experience, firewall did play a major role. So I had to disable firewall for the cross communication between ROS running on Windows and ROS running on Linux. Maybe, yeah, this might be because I have a domain joined device. So.
Yeah. I'm actually running Windows here with the firewall on. Okay. But I instigated the connection from Windows out. If it's instigated out in, that might be an issue.
Yeah, that's what I meant.
Okay.
The ROS master was running externally on a Linux device.
Actually, this is ROS master running on the Linux device as well. We should debug that.
Yep.
Any other questions? I'll be on the social when we transfer over to that.